Greetings, gentlemen, and welcome back to the Smart Video Lab. You're here with the Unit 3 and Unit 4 Midterm Review video based on the Unit 3 and Unit 4 Midterm Review Packet that you got in class. So let's go ahead and get started. And the first question says, in 1967, Carl opened a supply store in North Raleigh. From the time Carl opened the store, he was able to add $50 to his account each month. He had some money in the account when he opened the store. 4 months after the store opened, the account had grown to $360. As he tried to clean up his bookkeeping procedures, he realized he had lost the original deposit slip. Based on the information above, how much money was in the account when he opened the store? So let's look at the key information that we're given here in this problem. We've got this guy Carl, and he opened the store. He's adding $50 to his account each month. And he had some money in the account when he opened the store, but we're not sure how much. 4 months after the store opened, the account had grown to $360. So if he's adding $50 a month and the store was open for 4 months, that's 50 times 4, which is $200 that the store made in those 4 months. So the initial account balance would have to be $360 minus the $200 that they made over those 4 months, which is $160. Now it says write a rule to express how much money would be in his account using X for the number of months since the store opened. So let's let Y represent the amount of money in the account. The amount of money. So now remember, when we want to write a rule, we want to think, is this a linear function? Is the amount each month increasing at a constant rate? And it is, because it says $50 to his account each month. So we probably want to write a rule in either y equals mx plus b form, which is slope-intercept form, or point-slope form, which is y minus y1 equals m times x minus x form. And that's point-slope form. So since we're given the slope of $50 in his account each month, and we just found the y-intercept, the starting value of 160, let's write the rule in slope-intercept form. Y equals mx plus b. So it's going to be y equals 50x plus 160. And that rule represents the amount you get based on any number of months, x. So if we wanted to determine when his account would reach $1,000, we have to think about, is 1,000, this value, going to go in for x or y? Remember, we said let y represent the amount of money, and this is an amount of money. So that's actually going to go in for y. So we'll say 1,000 equals 50x plus 160. We substituted this value in for y in the equation from the first part of this question. So now this is just a simple linear equation that we solved like in Unit 2. So we can solve by subtracting 160 from both sides. And we'll get 840 equals 50x. So we divide by 50 on both sides. And we get x equals, we got to do 840 divided by 50. Which is 16.8. So that's after about 16.8 months. Now it says if he continued to get the same amount each month, how much did he have in his account at the end of 1 year, 5 years, and 20 years? So now in this case, and also at the end of 2012. In this case, we just want to figure out what these values are in terms of months, and then we can substitute for x in the rule, because remember x represents the number of months. So let's start with one year, which is how many months? That's right, 12. So 1 year is 12 months. My marker's tripping out for whatever reason. So now, in our rule, wherever there was an x, we're now going to put 12. So 50 times 12 plus 160. So when I compute that, I get 760. So after 1 year, there was $760 in the account. 5 years, the question becomes, how many months is that? So 5 years is 5 times 12, 60 months. So now we need to substitute in for x. 50 times 60 plus 160. So 50 times 60 is 3,000, and plus 160, that becomes $3,160. Now after 20 years, that's 20 times 12, 240 months. So y equals 50 times 240 plus 160. So by now this guy should be making bank. And let's see exactly how much good old Carl has put in the bank after 20 years. So that's $12,160. Now, for 20 years, that's really not that much money. So if I was Carl, I might consider another profession. But now let's look at 2012. So he started in 1967, as the problem said earlier. So if we look at 2012 minus 1967, how many years is that? When I subtract, I get, that's 45 years. And how do we figure out how many months that is? That's right. We multiply by 12, because there are 12 months in a year, so that's 540 months. So to figure out how much Carl's made in 2012, we have to do 50 times 540 plus 160. And when I do that in the calculator, I get $27,160 that he made in 2012. So that's problem 1 there for us. Let's go ahead and look at problem 2. There's a great show at the Grand Theater and tickets are all the same price. Shortly after the box office opens, the manager is told that so far the theater has sold 20 tickets. The cash register now contains $40. A little later, he is told that the theater has now sold 60 tickets and the cash register now contains $70. How much did the theater charge for each ticket? So we're given some interesting information here. Let's focus in on the mathematical information that we're given. We're told that they've sold 20 tickets and now the cash register contains $40. So we've got two variables going on here, tickets and amount of money made. So remember, X is always dependent. Sorry, X is always independent and Y is dependent because Y depends on X. So Y is the dependent variable. So in this case, does the number of tickets sold depend on the amount of money made, or does the amount of money made depend on the number of tickets sold? Of course, the amount of money made depends on the number of tickets sold. So X is going to be number of tickets and Y is going to be amount of money made. So now we're given a bit of information. We're told that 20 tickets led to a yield of $40. So we can think of points X comma Y, independent comma dependent. 20 tickets led to $40. So we have that point. And we can also see that 60 tickets led to $70. So we get that point as well, coming from this last sentence here. So 20 tickets goes with the $40, which gives us our first point here. 60 tickets goes with the $70, which gives us our second point here. So now the question is, how much did the theater charge for each ticket? So figuring out how much the theater charged for each ticket is comparing the amount of money to the number of tickets. In other words, we need to find the rate of change. And is it going to be constant? Are prices at most theaters usually the same? Well, it depends. But we're told in this case that tickets are all the same price. So no matter where you sit, it's the same price. So that's a constant rate for the ticket. So in this case, we're going to be finding the slope. So to find the slope, the rate of change for a linear function, we need to find change in y over change in x. And since we have 2 points, let's go ahead and look at the y coordinates here of these 2 points. Change in y is going to be 70 minus 40, and that's going to be divided by the change in x, which is 60 minus 20. So 70 minus 40 is 30, 60 minus 20 is 40, so that is simplifies to 3/4 or 0.75. And we're talking about y is amount of money, so dollars per ticket, because x is number of tickets, and it's change in y over change in x. So that's the slope, or the rate of change for this case, the amount of money that they're making. So now, part B says write a rule for how much money was in the register after P people bought tickets. So let's just write it in y equals mx plus b form, and then we'll change to P. So in order to do that, we need to decide, are we going to use slope-intercept form for a linear function? Remember, we said it's a linear function because the rate of change is constant. Y equals mx plus b, or y minus y1 equals m times x minus x1. So are we given the slope and the starting value, the y-intercept, or are we given the slope and a point? That's right, we're given the slope. Well, actually, we found the slope, and we're given 2 points, so we can pick one of those points. So let's pick the point 20, 40, just because it's smaller values. And remember, we said the slope, or m, is 0.75. So to write the rule, it's going to be y minus y1. Remember, points are always x comma y. So this is x1, and this is y1 here in this point. So this is going to be y minus 40 equals 0.75 times x minus 20 to x1. And now we can convert that into slope-intercept form just because that's nice and that'll tell us some more information. So we always want to distribute wherever possible. Remember, to get in the slope-intercept form, we just have to solve for y. So we'll get y minus 40 equals 0.75x minus, and now we need to figure out what's 20 times 0.75, and that is 15. Now we'll add 40 to both sides, and we'll end up with the equation in slope-intercept form, which is y equals 0.75x plus 25. So how much money was in the register before any tickets were sold? Well, we can actually tell that from the rule. So the rule that we just came up with is y equals 0.75x plus 25. So we said that 0.75x, that's the rate of change or the slope, and that means each ticket costs 75 cents. Now, the plus 25 represents the starting value, or the amount of money. In this case, since y represents money, so the y-intercept is talking about the amount of money that was in the register before we sold any tickets. Because remember, the y-intercept happens when x is 0. So in this case, the y-intercept, the amount of money when no tickets were sold, is $25, because that's the y-intercept of the function, which represents the starting value. How much money was in the register after 250 people had bought tickets? Remember, up here we said x is number of tickets and y is amount of money. So 250 people bought tickets. That means that needs to go into the rule for x. So y equals 0.75 times 250 plus 25. So when I compute that out, I get y equals 0.75 times 250 is 187.5 plus 25. That's 212.50. So $212.50 is the amount in the register after 250 people had bought tickets. So if you've watched the video so far, I'll go ahead and give you the secret code. Remember, it's 4 blanks. This is the third video, so the third blank is my. So it's blank, blank, my, blank. And I'm going to stop this video here and start the rest of the problems in another video.